Hey, everybody, it is Sherry Downer here at Tier 1 Interventions Podcast. It's great to have you here with us where we talk about the core of the math classroom. Today, we're going to be talking more about pizzas, rectangles, lockers. Oh my!
Back on March 10th, 2026, we started a 10-segment series in Proponent. Here is segment 9 from our October workshop. If you are enjoying what you are learning, please subscribe and leave a comment.
I think that was the right order. Over to Jonna Lee.
So when you're making rectangles and talking about which rectangles make squares, as a level 2 expert, these are the numbers that you're going to do in your seasons. Or if you teach higher grade levels, all of these numbers might be in season 1. Okay, so I teach algebra 1 and algebra 2. I've already done all of these numbers with my kids. In season 2, I'm going to pick a few new numbers, but I'm going to still go back to all of these numbers that I've listed. So my kids are going to get all of these numbers in all of the seasons. So Amy says, okay, so what am I talking about here? When we pick a number like 24, okay, Amy picks the number 24 with her first graders, and then she has them make all the rectangles possible. I listed some here, okay? So Amy says when she creates diamond problems, if I heard you right, and correct me if I'm wrong, Miss Amy, but when she creates a diamond problem for her first graders, she is going to be like, okay, 8 and 3. Because her kids have been used to making rectangles with dimensions 8 and 3. So 8 and 3, she's going to have her kids make a rectangle that is an 8 by 3. And then they're going to have grid paper. So they're going to see all of these, like I have 8 columns. If I do all of these, this is actually dividing the bar. This is paper folding. And then I have 3 rows. So kids don't create this rectangle. They actually, on grid paper, will show this 8 by 3 using grid paper. We're doing lots of skills here. And they're trying to figure out, what 8 plus 3 is, which is totally a first grade standard. Okay. And whatever they figure out for the sum of 8 and 3, that's going to be this bottom number. Okay. So we're practicing fluency and skill work through sensory reference tasks. And then whatever 8 and 3 multiply. Now, she's probably not saying multiply with her kids. Maybe she did. I don't know. It doesn't matter. But this top number is the multiplication of 8 and 3. But this top number for first and second graders, I call you're finding the array number. You're finding the array number. So first graders are still doing diamond problems. Thanks to Amy for teaching me this last time on how to deliver this to first and second graders. But this top number for first and second graders is the array number. I'm going to show you that in a minute because this is another task that these kids have done. For the rest of us, I put D because 8 is dimension 1 and 3 is dimension 2 on the dimension chart, meaning the length is 1 dimension and that is 8, and the height is the second dimension because I'm looking at a 2-dimensional shape. That's the 3. This number is going to be the array number because it's the number of blocks or squares it took to make the rectangle. Now, in third grade, this is going to become the area of the rectangle. In third grade and beyond, this top number is the area of the rectangle because area of rectangle is always product. It never changes. This is a transferable strategy, meaning the strategy doesn't expire when we get to new numbers or higher grade levels. We want to be repetitively doing transferable strategies. So this number in the diamond problem becomes the multiplication, the product. All multiplication is area. Third grade is where the standard is for area. So prior to third grade, see, we're doing all of this, but this is the array number. Now, how do I get an array number? Amy mentioned the dimension chart. Where does 24 go in the dimension chart? If I have my rectangle that has a length of 8, which we already saw visually, we built it with blocks. We drew it on grid paper. Now we're going to do it a little more abstractly with a dimension chart. And Natalie, this is what the classroom teacher was talking about yesterday when we were doing the height and weight. And she's, oh my gosh, this is like the other thing you did with them. And she couldn't remember what it was. And I said, it's the dimension chart. We have a 3x8. Now, this is what's tough for younger kids. And this is why I did the height and the weight yesterday. They have to follow straight on the connection of both of these, and then they have to circle the connector point, the connector box of 8 and 3. That connector block is the array number of an 8x3 rectangle. Now, the array number is the product. Later on, it's going to become the area. So if kids want to tell me the array number is 11, I'm going to say the array number is not 11 because 8 plus 3 is 11. That's only telling us how tall and how long together. I'm going to add 8 and 3. The array number is how many blocks did it take to make this rectangle. And then the kids have to figure out the array number is 24. Now, for all of you, this is a blank multiplication chart, but I call it a dimension chart because that's exactly how the multiplication chart is made. And that's exactly what a multiplication chart is. A multiplication chart are the products of all of the different rectangles with these dimensions. My high school students now see the multiplication chart. They're like, why didn't somebody ever tell me this? Because I would know my math facts, my single digit math multiplication facts so much better if I knew all of this connection. And that is why we do dimension chart. That is why we do making rectangles. And that is why we do locker problem. Because if I go to box 24 in locker problem, I want to know all the students that touched locker 24. Student 1 did, student 2 did, student 3 did, student 4 did, student 5 did not touch locker 24. I cannot make a rectangle with an array number of 24 using a dimension 5 to get, 24. John Lee, you were doing so good. Okay. Using number 5 as a height, unless I go into fraction or decimal side lengths, which is fine, and we're going to eventually do. I don't want to say I can't make a rectangle with dimension 5. I just can't make one to put in the dimension chart with whole number dimensions. I can make a rectangle with height 5, but it's just not going to give me a whole number side length. And when we're focused on making rectangles in dimension chart, we're focused on whole number side lengths. So I can't do it with a whole number. I can't land on 24 with student 5 if I want whole number outcomes. I can do it later. I can do it later because I can have a non-whole number side length with a height of 5 with an area of 24. I'm not going to worry about that right now. I can do it. I just can't do it with whole numbers. Then, but student 6 can pair with student 4 because a 4x6 rectangle makes 24. But what pairs with student 3? So if student 3 touches locker 24, student 8 also has to touch locker 24. There's another rectangle, 8x3. That's the one we charted. Another rectangle is 12x2 and 24x1. So all of the students that touch those lockers are the whole number dimensions of the rectangles when 24 is an array number or the area. So 24 is the array number, but there's lots of places in the dimension chart based on the locker problem that 24 can go. Guess what? we can do a 6x4. So this is also the connector block for 6x4. This is also a 24. So the locker problem can tell us which students touch that locker. Once we know which students touch that locker, those are the whole number dimensions for the making rectangles. And then once I know all the dimensions, I can plot all of my locker numbers on the dimension chart. There are more locker numbers than others with 24 because 24 is going to show up lots of times on the dimension chart. 11 isn't going to show up very many times on the dimension chart. So I could ask another question. Where does 11 go on the dimension chart? Where does 11 go on the dimension chart? And how many times will we see 11 on the dimension chart? And I lost my train of thought. How many times do we see 11 on the dimension chart? And how many rectangles with whole number dimensions can be made with a area or array number 11? And so now I can facilitate with these task dependent questions. The only way kids can answer these questions is if they have engaged in these tasks: locker problem, making rectangles, dimension chart, diamond problems. The only way kids can answer these questions, task dependent questions, is if they've experienced these tasks. And now, when I say to students, what are the factors of 24 at any grade level? And kids are like, I don't know. Now, I have two choices as a teacher. I can either be like, you need to figure out what the factors are, or I can just tell the kids the factors. Now I have a third door. Sherry knows what I mean by third door, the third way. Okay, there's always a third way. We think as educators that it's either this way or that way, and that those are all my options. There's always a third way. In the Mastery Math method, the third way is to support students through reference tasks. So when my kids struggle, even my high school kids don't know how to get the factors of 24 or don't know what factors mean, I can now say, what dimensions?
Jonalee, I want to close out Tier 1 Interventions podcast. And that is, if you are listening to this podcast and you are thinking, how do I get involved? You want to head over to your show notes and click on the link. We are offering you to come to a session like this, where you get all 2.5 hours at one shot for $47. You can then join another session for another $47, or you can buy the whole year for $497. Plus, you have to buy if you're going to go buy the whole year, you're going to have to buy level 1 as well. But the coaching and these conversations that we're having are $497. That sounds to me like a really good deal to really think the way you're thinking about not just mathematics, but occupational therapy delivery, speech therapy delivery, special ed delivery, and how we're helping these kids rethink, re-regulate, relearn, and think about life as whole.